In this video, we're going to talk about tracing functions. Tracing is probably one of the most important skills in order to become a top-notch computer programmer. So, what is tracing? Tracing is just a fancy term for executing each line of code in a function, just like your computer would do. Being able to look at a function and know what each line of code does is important in not only developing your own programming skills, but it's also key in being able to find problems or bugs that might show up in the programs that you write. So there are three basic steps in tracing through any function. First, you're probably going to have something calling your function, and most functions have inputs. So the first step that you need to do is you need to translate your inputs from one scope, the scope that's calling your function, into the actual scope of the function itself. After you're inside of the function, then you need to execute or move through each line of code and figure out what are the values that are being produced through each line of code. After you've moved through each line of code, the last step is translating your outputs from your function scope back to the scope of whatever called your function. So now let's do an example of tracing a function. On this slide, we have all the parts of a typical tracing problem that you might see. So first, we have a function. We have a function and the lines of code inside of it. Then we have our command window. So inside of our command window, we are executing certain lines of code and we're calling that function that's defined above. And then we have the question. So the question reads as follows. After the lines of code are run in the command window, what are the values of the following variables in the command window workspace? So let's tackle this problem step by step. So the first step, like we talked about on the last slide, is to translate your inputs. So we're starting in our command window. Our command window is what's calling our other function. So the command window, like we talked about before, has its own scope. It has its own place in memory where its values are stored. So I'll denote the command window scope by this box right there. And I'll label it as CMD for command window. So let's go through the command window line by line. So the first line here, we have 10 being assigned to A. So inside of our command window workspace, we have a variable A created, and its value is 10. The next thing that happens on this next line is, on the right-hand side of the assignment operator, we're calling a function. So since we're calling a function, we're going to have to translate our inputs. So since we're calling a function here, the name of our function is myfunc, and we're saying we want the input to be the variable A. So once we see this, we know that now we're going inside of the functions workspace. So I'll denote this as this box and have myfunc. Okay. So once again, the first step is to translate your inputs. So inside of our command window, we're placing the variable A, the value inside of the variable A, inside of the function. So therefore, this value is placed inside of the variable that we dictated to be our input in our function header. So now it's very important to note that although these variables are named the same thing, they are two completely different variables. Okay, so right now the first step is we're going to translate our inputs. So the value of A, which is currently in the command window, which is 10, is placed inside of myfunc in the inputs, and the input just so happens to be called A as well. And here A is given the value of what it is in the command window. So we have A is equal to 10. And then now our next step is to move through and execute each line in our function. So let's do that. So in our next line here, we're doing the right-hand side of the assignment operator first. So our current value of A inside of our myfunction workspace, or inside of our myfunction scope, is 10. Okay, so then this is substituted with a 10 here. So then we have 10 minus 4, which is 6. So therefore, in our function workspace, we create a variable called B, which is given the value of 6. Okay. Now we move on to the next line, and we have A plus 1 on the right-hand side of our assignment operator. So the current value of A is 10. So once again, this is substituted there. And the right-hand side is equal to 11, and we're reassigning that to a. Okay, so now we are only working in the function scope. So this variable a that's inside of the myfunc scope is changed to 11. Notice nothing happens to the variable a that's inside of my command window scope. Two completely different variables. They're named the same thing, but they're two separate entities. So let's move on. So in the next line of code, we now, on the right-hand side of our assignment operator, we have a plus b. Our current value of a was just changed, so the current value of a inside of myfunc is 11, and the current value of b inside of myfunc is 6. So we have 11 plus 6, which is 17, and we're assigning that to our variable out. So out is given the value of 17. Okay? So then now we move on to our last step. Once we're done with our function, now we need to translate our outputs. So in our function header, we told MATLAB that we want to output whatever is inside of a variable called out. Okay? And right now we have the variable out defined, and its value is 17. So now we need to translate this value back into what called it. So the line in our command window is what called it. And we're going to assign that value of out back to the variable b inside of my command window. So inside of my command window, b is equal to the value that out is. So we're passing values there, which is 17. Now, once we finished our function, once we finish running our function, all the variables, or our whole memory, is erased. Okay? So all of this goes away. We don't remember anything about those intermediate values. All that's remembered is what's passed back from one scope to another. So then now, our second line of code in our command window is done, and now we can answer the question. So inside of our command window workspace, right, so that's this one, right there, we want to know what's the value of a. So the value of a inside of the command window workspace is 10. Okay. Once again, this a is completely different from the a that was inside of the function. Writing out the two scopes this way helps make doing these types of problems a lot easier. You don't get confused with all the variables that might be named the same thing. So the second question is, what's the value of b? Inside of the command window workspace, b is 17. All we have to do is just read the values from our boxes. And lastly, it asks, what's the value of out? So does out exist in our command window workspace? No, it was only a local variable that was inside of our function. So therefore, outside of that function, if we tried to ask for that variable, MATLAB doesn't know what you're talking about, right? So this, if we ask for out, this would give us an error. So anytime we try to reference a variable that doesn't exist, we get an error. So this is the basic steps in tracing through, or going through any tracing problem on any function.